everyone, welcome to our new video on our YouTube channel, that is TwoSum. It is tagged as an easy problem, and this problem is about finding the two sum, like where two elements add up in an array to a target value. For example, if you see this array, so here 2 and 7 adds up to 9, that is your target value, and the output is the indices. For example, here the array starts with index 0, this is index 1, so we are just returning the indexes of the array, right? That is what mentioned here. Similarly, if you see target 6, so here if you see target 6 is found by index 1 and index 2, so hence we return 1 and 2. Okay, then index we have to return then 6, so 6 is returned as 0 and 1. So if you see the indexes are distinct, you don't have to return 0 and 0 again. Okay, so it has to be distinct. That means this makes sense. So let's go through the problem. Given an array of integers and in target, return the indexes of 2 that sums up to the target. You may assume that each input would have exactly one solution. So, okay, this is a crux of the problem where you would only have 2 indexes which you can return. Okay, you may not use the same element twice, which I just explained in this case, right? And you can return the answer in any order, which is also fine. For example, you can return 1, 0 also in this case. Okay, this makes sense. If you go through the constraints, so array length is quite small, right? So this is there. Nums of I is like within integer range. Okay, and only one valid answer exists. Okay, so if you see this problem, so how do you think it would be solved? So basically the problem can be solved as, for example, in this array, if you see 0 index and 1 index makes 9, but how would you know that you have found the previous element? So if you see, if you subtract 9 from 2, it makes it 7. So when you are at index 7, I mean at the element 7, then you should know that 2 has occurred before, right? So obviously you have to store this value, right? So if you know that 2 has happened before, that means you have got the answer, because you just need 2 values which sum up to a target value, right? So how could we store it? That is the first question. So you can store it using an unordered map in C++. I will be coding this in C++, and what you can do is you can store the index. For example, once you find 2, okay, you will say 2 has happened at index 0. Now when you are, you will find the sum. Okay, so let's say when you are getting 7, then you will see that whether target minus nums of I has happened before or not. Okay, if this has happened before, that means you have got your index. So your answer would be what? Your answer would be I comma your unordered map. Let's say the map is mp comma target minus nums of I. This would be your value, this would be your answer. So when you come to 7 index, this is the first iteration. When you come to 7 index, then you won't be needing in this case. So I think this is not a great example. Let me move to the other example. So for example 3 to 4, this is the array. ये आपका array है. उसके बाद what we will do, where this is mapped to index 0, so we will say mp of 3 would be 1 or 0. Okay, and what is the target? Target would be 9, and in the first iteration you store this, and then let's say you go and try to find what is the other value, for example 2. So what would happen? You will not get the value, but what you would get, the sum would be 2. So you can store mp of 2 is equals to 1. But does target and target, what would be the value of target minus nums of I? That is, target minus nums of I would be 6 minus 2, 4. Has 4 happened before? No. 4 happened? No, right? 4 has not happened, right? So this is trivial, but what would you do in this iteration? You would store mp of 2 as 1, right? Now when you move to the other value 4, then you need not to store. You will first check whether target minus 4, that is 2, has it happened before? Yes. So you will get yes, and if you get it yes, then obviously you have found the answer. So let's try to code this. So how would it happen? You are traveling in a linear fashion, so the time complexity would be order of n. You would be storing it in a in an unordered map, so the time complexity would be order of n, and the space complexity, because you are storing each element once, so it is going to be order of n. Okay, so let's move on. So I will try to code this. So for example, you take unordered map of integer comma integer mp, right? You will take n is equals to nums dot size. If let's say n equals to 0, that means it is an empty answer. Then you did not do anything, you just return an empty vector, right? And let's say what happens next. Now you got n, which is the size. So obviously you can iterate int I is equals to 0, I less than n, I plus plus, and you will just try to find int value. Let's say you tell it to be target minus nums of I, and you say if my map dot find value is not equal to empty, it is not, that means it has found the value, then what you can return. Why I'm returning? Because you have to return only one answer, you don't have to store it. So your answer would be actually, since the value has happened before, so mpf value, I'll return it in ascending order of indexes, so this is fine. And what else you can do is mp of nums of I equals to I, where you are storing the indexes, right? So this makes sense, and if you don't find anything, you can return an empty vector, right? So let's try to run this code. I don't see any compilation issues as such, so let's try to run it. Okay, all the three cases pass. I submit it. This is perfect, right? So all the cases have passed. So this is pretty cool. So what you understood here is that this is a problem of HashMap, where you have used HashMap. This is unordered map, so it would be using hash set internally. So the time complexity for getting the value and finding the value would be order of 1, rather than if you would have used a simple map, it would be order of log n. So that optimizes it. So I would say time complexity is equals to order of n, and space complexity is also order of n, right? So why this is great question is because let me move to this solution, and can you come up with algorithm less than order of n square? So obviously we came up with order of n solution, right? Order of n square would be typically you iterate from I to n, and then j from I plus 1 till n, and then you try to find all the pairs. That would be n square, and which is not required actually. So this makes sense. I hope you learned something new today, and thanks for watching. Like, subscribe our channel. We also run a Discord community. You can find the links in the description of our channel,